Hello, you may have seen this lesson prior to this one before, maybe not, but either way I'd like to start with this experiment. Here's a test tube of hot water which is placed inside a beaker of cold water and the temperature measured as time goes by. This animation shows what's going on more clearly, with the higher temperature being a darker green. The animate words. I won't explain now why it's wrong to use the word temperature but it is better to use the word heat, and it's even better still, and the way I'd like you to learn, to use the word energy. Energy is moved from the hot water in the test tube through the glass to the cold water outside. As I say, you may not appreciate it now, but it's very important to use the correct words. Look at these clips of natural phenomena. The total run time is about 5 minutes, and there'll be a question at the end.
The sun burns for billions of years because it turns mass, matter, substance, stuff, whatever you want to call it, it turns it into energy. You get a good return when mass is converted into energy, a lot of energy for every kilogram. And the sun is massive, so it gives out a lot of energy for a long time. It has billions of years to go before it finally runs out of energy. In fact, if you could turn all your mass into energy, you could give off as much energy as 20 atomic bombs. This is a weird thought, and just as well that you can't. Quite often the sun gives off what is called a solar flare. A reasonably large bomb will send as much energy into space as 1 billion atomic bombs, and loads of particles and rays that could kill us if it wasn't for the Earth's magnetic field protecting us. The sun's energy shines down on the Earth. It makes the plants grow, and the energy is stored up in leaves and in the wood of the tree trunks and the branches. Animals eat the leaves, and the energy is moved from the leaves to the animals. If those animals get eaten, then their energy gets moved on to the predator. The energy gets stored up and moved around all the time. That's one of the things that you need to learn. The Earth's core that produces a magnetic field that protects us from solar flares also provides energy from the inside of the Earth. Sometimes this energy explodes out in the form of volcanoes. When Mount St. Helens in the United States erupted in 1980, it exploded with the energy of 500 atomic bombs. In ancient history, there has also been evidence of superplumes, giant volcanoes perhaps 8,000 times as big as Mount St. Helens. If one of these blew in modern times, it would be very bad news for all of us. Lightning is another impressive show of energy. One thunderstorm can contain an amount of energy equivalent to 4 days' use of electricity for the whole of the United States. A bolt of lightning travels at 435,000 kilometers each hour and can heat the air around it to 28,000 degrees centigrade, several times hotter than the surface of the sun. At any one moment, 1,800 thunderstorms are in progress around the globe, some 40,000 every day. Day and night, across the planet, every second, about 100 lightning bolts hit the ground. The sun causes water to evaporate from the oceans, and if the conditions are right, tropical storms and hurricanes can occur. A tropical hurricane can release in 24 hours as much energy as France or Britain uses in a year. If only it was possible to store up all of the wind energy. Wind energy. That's a funny term. And that is the problem of saying that there are types of energy. It is difficult to know where to stop. Wind energy, heat energy, stored energy, food energy, movement energy, dust energy. It's all just energy, really. However, sometimes it is useful to talk about energy being moved from one store to another, just like when the leaves were eaten by the animals. Take a look at the next clip. It's one of my favourites. The photography is superb. It's an avalanche.